This is the second part of Lesson 11-5, and we're going to talk about ratios and proportions and volume. And of course, with volume, we're talking about three-dimensional solids. So we kind of have to talk about this idea first here. What does it mean if two solids are similar? And it's got some good information here that I would hope that you read through really closely. The heart of the matter is right here. It says two polyhedrons are similar if all their corresponding faces are similar and the lengths of their corresponding edges are proportional. Alright, so let's do a little checkup on that first. Let's check the ratio of the edges here. So here we have a height of 2 and 2, so the ratio there would be 2 to 2. The width would be 3 to 6, and the length would be 7 to 14. Alright, and this ratio would be 1 to 2, this ratio would be 1 to 2. However, this ratio would be 1 to 1, and so all the three ratios aren't the same. So the question here is, are these two similar? The answer is no, because the ratios of their sides are not all the same. The edges are not all the same. Over here, the radii in the cone is 8 to 12, and the heights are 14 to 21. So let's simplify these. 2 goes into there. Oh, let's use 4. 4 goes into 8 2 times. 4 goes into 12 3 times. 7 goes into 14 twice, and 7 goes into 21 3 times. Look at that. They're the same. So are these two similar? And the answer there is yes, they are similar. Alright, so before we can talk about using proportions and ratios in volume, the first thing that you must have is two similar solids. Okay, so if you don't have two similar solids, you cannot use ratios. Alright, so let's take a look at a couple of examples. So here I have two cylinders. The cylinder on the left has a radius of 2 and a height of 8, and the cylinder on the right has a radius of 8 and a height of 32. So the first question here is, what is the ratio of the radii? So the ratio would be 2 to 8. And let's simplify that. So the ratio is 1 to 4. So the next question here is, what is the volume of each cylinder? So let's do a quick calculation here. So remember, volume is area of the base times the height. Volume area of the base would be pi r squared. The radius is 2. 2 squared is 4. So 4 pi times the height of 8. And that would make this 32 pi. Alright, let's talk about this one over here. Same idea. Volume equals area of the base times the height. The base in this case is 8, or the radius is 8, and pi r squared. So pi times 8 squared would be 64 pi, and the height would be 32. So I've got a calculator here by my side. I'm just going to use that. I'm going to multiply 64 times 32. And the volume turns out to be 2,048 pi. Alright, so I've got the volume of each of the cylinders. Now let's make a ratio out of that. So 32 pi to 2,048 pi. Now, you might think that there's no relationship there because the numbers get so large. But what I want to do right now is I want to take 2,048 and I'm going to divide by 32. Alright, and so if I simplify this, it turns out to be a ratio of 1 to 64. 32 goes into 2,048 64 times. So I've just simplified this ratio, that's all. Now this last question is the key. What do you do to the ratio of the radii? So that's this right here. What do you do to that to get the ratio of the volume? So let's just do that math right off to the side here. So the biggest difference between area and volume is, area we compute in two dimensions, and volume we add a third. And so let's just try an experiment here, and let's cube this. Alright, so that'd be 1 over 4 times 4 times 4, which is 1 over 64. Wow. Look at that. And therein lies the key. So the big idea is, if you know the ratio of, in this case, since it's a cylinder, we have the radii, but it works with cubes and rectangular prisms, pretty much everything that you can find the volume of. If you know that ratio of two similar solids, then you can cube the ratio, and that will give you the ratio of their volumes. Okay, so now that you have an idea of how to find that relationship, let's look at how you use that. So here's an example. Just text. I don't even have any pictures in here. So my advice is always to draw a picture of it. Alright, but it just says the ratio of the radii, that can't be right. The ratio of the edges of one cube to another is 1 to 4. So I'm going to write that right here. Alright? And then it says the volume of the smaller cube is 16 cubic centimeters. What's the volume of the larger cube? Alright, so we have the ratio of the edges of the cube. To find the ratio of the volume, I need to cube this ratio. 1 cubed is 1, and 4 cubed is 64. So the ratio of their volumes is 1 to 64. The volume of the smaller cube is 16. I'm going to put that on top because it's in the same position as the 1 here. And I'm just going to call the volume of the larger one V. So let's cross multiply. 1 times V is V. And 64 times 16 is 1,024. And that would be cubic centimeters. So that's an example of how you use this. If you're given the ratio of their sides, you can cube it. That will give you the ratio of their volumes. Alright, let's wrap this up. Here is the big idea. So the big idea is that the ratio, if the ratio of their sides or radii, if it's a cylinder, is m to n, then the ratio of their volumes is m cubed over n cubed. Cube that ratio to find the ratio of their volumes. Okay, I want to remind you that these topics of ratios and area, ratios and volumes, are a required topic for the Washington State end of course assessment. Get to know these as much as possible. I guarantee you're going to see problems like that on your exam that is required for graduation from high school.